Hello friends. In this video, we will be solving a problem based on k-means clustering. Let's say we are given these 10 data points, right? And we have to group them into 3 clusters using k-means clustering. So given to me is the value of k is 3. I need to form 3 clusters, right? So in k-means clustering, step 1 says randomly select centroids of k clusters. So here k is 3. So I will be selecting the 3 centroids. Centroids of k clusters. Let's say we have selected C1 as 0.15, C2 as 4.1, and C3 as 8 and 4. Okay. Now, let's move on to the next step in k-means clustering. What we have to do, now we have these centroids, right? For each of the data points, I will be assigning the cluster to them, which is nearest to that. How to find out the distance between a data point and a centroid? I'll be using a Euclidean distance for that. Okay, so my step 2 says assign each data point. In our case, we are having these 10 data points, right? So for each of these data points, I will be assigning it to its nearest cluster center. Using the distance matrix, that is your Euclidean distance. Okay, so let's say we are given 2 points. Okay, so we have x1 here and x2. 2 points are there, right? So I need to find the distance between these 2 points. Okay, how to find that distance? Let's say the coordinate of this is your xy, right? And here you are having p and q, right? So if I am finding out the distance between these two, using your Euclidean formula, okay. So the distance between this, let's say this is d distance, is equal to the p minus x whole square. Then I'm adding the q minus y whole square. Okay. So using this, I will be calculating the distance between the centroid and each of the data points, my 10 data points. Okay. So this step says we will be calculating a distance of each of the given data points from C1, from C2, and finally from C3. Let's say we have the point P1 here, which is 2, 4, right? So x coordinate is 2, y is 4, right? So I need to calculate the distance between this and the centroid, 1, 5 first, right? So simple, you just put it into the Euclidean distance formula, right? So I'll be getting 1 minus 2 whole square plus 5 minus 4 whole square. Okay, so this is my distance P1, C1. Okay, this comes out to be square root of 2. That is approximately 1.41. Okay, similarly, I will be calculating the distance of P1 with centroid C2, second cluster. Okay, and if you're going to solve this again, I know the value of C2, which I have selected, is 4, 1 coordinates. Okay, so 4 minus 2 whole square plus 1 minus 4 whole square. That comes out to be square root of 13, which is approximately 3.61. I'll be calculating the P1 with C3. Okay, I know the coordinate of C3 is 8, 4. Okay, so distance between 2, 4 and 8, 4 we need to calculate. Okay, 8 minus 2 whole square, 4 minus 4 whole square, that comes out to be 6. Right? Now we need to compare them. Compare P1, C1, this value, P1, C2, and P1, C3. So that will tell me the distance between the point P1 with C1, C2, and C3. So from this, we found that this value is the minimum distance, 1.41. That means the P1 is nearest to cluster C1. So I will be assigning P1 to C1. Okay. Similarly, we'll be calculating for rest all 9 points. P2 के लिए आप same calculate करेंगे. We'll be finding out the distance of P2 with C1, P2 with C2, P2 with C3, and then you compare which distance is minimum. And that particular cluster center will be assigned to the P2, and so on. Okay, so here I have done the calculation. So you can see for first point P1, 1.41, that is the centroid of cluster C1, right? This is a minimum distance. So I am assigning cluster 1 to the point 1. Okay, and for point P2, again I am having this value that is with respect to cluster 1. So P2 is also assigned cluster 1. For P3, we can easily see cluster 3. The distance between P3 and C3 is minimum. So P3 will be assigned the cluster 3. Okay, and so on. You can just check that, right? So this is your second step. What we have done, we have randomly selected some centroid points, and then we have assigned each of the data points to these centroids. Okay, you can calculate for rest all and verify this. Right, so let's move on to the next step now. Step number 3. What we have now, we have the data points, right? And then they have been assigned to the particular centroids or a cluster, right? So this is my iteration 1, which we have done so far. This initially my points were there. Now I have assigned it. I have shown them with different color. So for C1, you can see here I have shown with green color, right? So all the points which belong to cluster C1 are shown here with green color. You can just check here, right? From this table, you can verify the result. Similarly, for cluster 2, with this purple color, so these 2 points are there. And then rest all points are for the cluster 3. Okay, these are the, right now, after first iteration, this is my result for data points. Okay, these are your randomly selected centroids. Now what we have to do, step 3 says we need to recalculate the centroid, because now I have some data points. Okay, let's say these are the, this is your cluster, 1 cluster. Okay, so it has these 2 data points. So when I will be calculating the centroid, this will get changed now, right? So I need to calculate the centroid now, again the new centroid. Okay, so step 3 says calculate new centroid for each of these clusters. So in our case, we have 3 clusters. Okay, how to calculate the centroid? Centroid is the mean. Okay, so the mean of the data points which are assigned to that particular cluster. So let's see, for C1, if we need to calculate the new C1 will be, you can just check here. we have data point 1 belong to C1, data point 2 belong to C1, and data point 4 belongs to C1, right? So I'll be taking the mean of these 3 points, okay? That is going to give me the centroid. So it's 2 plus 2 plus 4 divided by 3. Okay, this will be the 1 point, okay? Next coordinate, y coordinate will be 4 plus 6 plus 7 upon 3. So that comes out to be approximately 2.66 and 5.66. So this is my new centroid with respect to cluster 1. Similarly, I will be calculating for C2, right? And then for C3. For C2, I can see P7 and P10, right? 2 data points are there. So I'll be taking the average of these 2. So that comes out to be your 4.5 and 3. Right? Similarly, for C3, we have the points P3, P5, P6, P8, P9. Okay. So you can just take the mean of these values divided by 5. So that comes out to be 6.5. So this is my new centroid. Now what I have to do? I have to again check each of the data point, and I will be reassigning these data points to these new centroids. Okay, that was my step number 2, which we have done. So I have to repeat this step 2. Okay, I will be reassigning the points, and I will see now, is there any change in that? Okay, so let's reassign them. So I can see from this table easily, there is just a small change, right? Rest all the points are same, only the 9th data point has been shifted from the cluster C3 to C2. Okay, so you can see from the diagram also here, there is a change. This point is my 6,3, right? So I marked with this hash, you can check it. Earlier it was marked red, C3. Now, when we calculated the new centroid and then we assigned the data points, it came to the cluster number 2. We can easily visualize it also. These are more close together. These data points are more close together, right? That's our intent of doing the k-means clustering, right? The points, how it grouped together the points based on the similarity. What similarity? With the points which are similar, which are having the closely placed, okay? The distance between the data point and centroid is less, right? I will be assigning those points into one group or one cluster, right? So this is my iteration number 2, right? So we have reassigned the point distance, we have recalculated the distance, and then we have assigned the cluster to them. Okay, and then we have observed, yes, there is a change. There is a shifting, some switching of the data points from one cluster to another cluster. So I need to recalculate their centroid. The same process, I'll be taking the mean or the average of the data points which belong to a particular cluster. So the new centroid comes out to be this. This will remain the same. There is no change in this cluster C1. So it will remain the same as earlier. C2 will get change and C3 will get change. Okay. Now, again, I have to repeat this step 4. What was that? You have to recalculate, right, this distances based on the new centroid. And then you will assign the cluster to them. And we will see whether there is a change or not. That means whether there is any switching of data points between the clusters or not. Okay, so we will keep on repeating this till the convergence. What is the condition of termination here? until there is no change, no switching of data points between the clusters, right? After multiple iterations. Another criteria could be, let's say we have done so many iterations and still we are finding, okay, there is 1 or 2 points which always get shuffled. Okay, so we have to fix one threshold value. Okay, we will move on to maximum number of iteration, let's say 50 iterations only, and then we will stop. So we'll keep on iterating, we will keep on training until 50 iterations are reached, and then we will stop there if we are not able to converge. Okay, so these two are the terminating condition. Okay, so let me summarize the step 4, which is the last step now. I need to repeat the above 2 steps only. Step 4 says, repeat the step 2, recompute the centroids, assign the data points to the new centroids. Okay, until there is a convergence or the terminating condition, which I have just explained you. Okay. So if there is no change, very good, you have done with this finally. Otherwise, you have to repeat the steps. Okay. Right. So you can see here, for iteration 3, we can see only, again, there is a change. One data point get switched, right? This was there. You can just see this point earlier belongs to cluster 3, right? And we can easily visualize it is more close to this cluster, second cluster, right? So in the next iteration, we have visualized that this has come to this particular cluster, this point. Okay. So the points which are closely placed are assigned to a same cluster. Okay. And for next iteration, what we have observed, this point you can see. Earlier it belonged to first cluster, now it belonged to cluster number 3. Again, this is good because these points are closely placed together. So they should belong to one cluster. So this is my one cluster, right? This is another one. And the third cluster is this. Okay. So we end up with these 3 clusters. After this iteration number 4, okay. So again, when we have calculated this distances from the new centroid, we found that there is no change. You can just see this cluster, assigned clusters, there are no change in the data points. So we will terminate the process here. No movement of data points, no switching of data points between the clusters. So I will end up here. And these are my final centroids for the 3 clusters. And the data points are this. So cluster 1, the data point 0.1, 0.2 belong to cluster number 1, 0.3, 4, 6, and 8 belong to cluster number 3, right? And then 0.5, 0.7, 0.9, and the 10th point, they belong to one cluster, that is second cluster. Okay. I hope this is clear to you all. Thank you for watching the video.